Physics aims to understand the universe's fundamental laws. We're going to tell how brilliant ancient minds studied and discovered physics laws, and how complex phenomena arise from basic principles. Physics employs observation to study natural phenomena. Experimentation is used to validate physical theories. Mathematical formulation describes natural phenomena. Physics seeks to predict future events based on current understanding. Early physics began in ancient Greece with figures like Pythagoras and Archimedes. They established the groundwork for scientific inquiry. Their work integrated mathematics and observation. They created foundational concepts in geometry. They also made key contributions to mechanics and hydrostatics. The Renaissance saw a blend of art and science, exemplified by figures like Leonardo da Vinci. This era initiated a move toward empirical observation and hands-on experimentation. Established doctrines were questioned, promoting a spirit of inquiry. This shift laid essential groundwork for the development of modern scientific methods. Breakthroughs marked a pivotal transition in understanding the natural world. Modern physics explores space-time, relativity, and cosmology. These concepts redefine our understanding of gravity. They also reshape how we view the universe's structure. Modern physics studies matter's behavior at cosmic scales. Relativity explains gravity as space-time curvature. Cosmology studies the universe's origin and evolution. Quantum physics studies matter's behavior at the subatomic level. It reveals counterintuitive phenomena challenging classical physics. Quantum mechanics operates on probabilistic rather than deterministic laws. Particle physics explores matter's fundamental constituents. It investigates the forces governing interactions between particles. That's what is going to happen in this channel section. Enjoy the journey through the millennia. Block 1. Pythagoras and the mathematical soul of sound. Pythagoras found that string length ratios create harmonious tones. Simple ratios in string lengths produce pleasing musical intervals. A string twice the length yields the same note one octave lower. This discovery linked math and music through numerical proportions. These ratios underpin musical harmony and scale construction. Pythagoras explored string length ratios to understand musical harmony. A 3:2 string length ratio produced a perfect fifth interval. A 4:3 string length ratio resulted in a perfect fourth interval. These experiments revealed the mathematical foundations of music. Pythagoras linked specific numerical ratios to pleasing musical intervals. The frequency of a vibrating string is related to tension and length. Frequency is proportional to the square root of the tension. Increasing tension raises the frequency and pitch of the string. Decreasing the length of the string also raises its frequency and pitch. Pythagoras proposed that celestial bodies move according to musical ratios. This concept suggests a mathematically harmonious structure to the cosmos. He called this celestial harmony Musica Universalis, or music of the spheres. It reflects a belief that the universe is governed by mathematical principles. These ratios were thought to create a cosmic symphony imperceptible to human ears. This theory linked mathematics, music, and astronomy in a unified worldview. Block 2. The Secrets of Syracuse. Archimedes and the Crown of Gold. King Hiero II doubted the purity of his gold crown. Archimedes was tasked to determine if it was fraudulent. The challenge was to do so without damaging the crown. This set the stage for Archimedes' famous discovery. Archimedes, in a bathhouse, observed water displacement by an object. He discovered the volume of displaced water equals the object's volume. This insight led to the formulation of the principle of buoyancy. Buoyancy explains why objects float or sink in fluids. The buoyant force is equal to the weight of the fluid displaced. Archimedes' discovery has broad applications in physics and engineering. Gold is denser than silver, meaning it packs more mass into the same volume. A crown made of pure gold will have a specific volume for a given weight. If silver is added, the crown's volume will increase for the same weight. The adulterated crown will displace more water than the pure gold crown. Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object. The buoyant force equals the weight of the fluid displaced by the object. If the buoyant force is greater than the object's weight, the object floats. This principle explains why some objects float while others sink in a fluid. Archimedes designed the Syracusia, a giant ship, to showcase buoyancy in engineering. The ship's design demonstrated practical applications of scientific principles. It was built in Syracuse harbor, highlighting the city's maritime capabilities. The Syracusia was an ambitious project, pushing the limits of naval architecture. Archimedes' work on the ship advanced understanding of fluid dynamics and ship design. Block 3. The Master of Equilibrium, moving the Earth. A lever acts as a force multiplier, enhancing the effect of an applied force. It allows a small force exerted over a long distance to move a larger weight. The trade-off is that the large weight moves only a short distance. This principle enables lifting heavy objects with less effort using leverage. Torque is a turning force. It's quantified by force applied. Multiply force by distance. Distance is from pivot point. Principle governs gears, joints. A seesaw demonstrates the principle of leverage in a simple visual way. Leverage allows a smaller force to lift a larger weight. The lighter child sits farther from the pivot point. Fulcrum. This increases the leverage, magnifying the child's force. The increased leverage enables the child to lift the heavier adult. Archimedes employed levers to gain mechanical advantage. He also designed cranes for lifting heavy objects efficiently. These machines were used to lift Roman warships. This demonstrated the power of applied mechanics in warfare. The Archimedes screw is a device used to transport water uphill. It operates using a rotating spiral encased within a cylinder or pipe. As the screw rotates, it scoops water and moves it upwards. This mechanism effectively defies gravity through rotational mechanics. Archimedes screws are still used today for irrigation purposes. Block 4. The War of Light. Archimedes' defense of Syracuse. During the Roman siege, Archimedes turned to optics for Syracuse's defense. He understood light's predictable path and properties. Archimedes sought to exploit these properties to thwart the Roman forces. His focus was on using light as a weapon. This involved innovative applications of mirrors and lenses. The goal was to disrupt and disorient the attacking Roman fleet. The law of reflection is a fundamental principle in optics. It describes how light behaves when it encounters a reflective surface. The key concept is that the angle of incidence, the angle at which light strikes the surface, equals the angle of reflection, the angle at which light bounces off the surface. Therefore, light reflects from a mirror at the same angle it hits the mirror. Archimedes conceived a method using mirrors to focus sunlight. The design aimed to concentrate solar energy onto Roman ships. This concentration could potentially ignite the wooden ships. The mirrors would act as a large, focused lens. The focused sunlight would generate intense heat on a single point. This heat could surpass the wood's ignition point, causing fire. The genius of Archimedes goes further and applied his understanding of physics to military technology. He designed catapults using the center of gravity for stability. Stable catapults improved accuracy and reliability on the battlefield. Range was adjusted by modifying the projectile's weight. This allowed for precise targeting at varying distances. Block 5. The Renaissance Awakening. Leonardo and the Ghost in the Machine. Leonardo da Vinci studied friction, a force resisting motion between surfaces. He observed that friction arises when surfaces rub against each other. Da Vinci recognized that this rubbing leads to energy loss. He understood that energy dissipates as heat due to friction. Friction force is determined by two key factors. It equals the coefficient of friction multiplied by the normal force. The coefficient of friction reflects surface stickiness. A higher coefficient means a stickier surface. A lower coefficient indicates a slippery surface. Friction is a force-resisting motion between surfaces in contact. The coefficient of friction, COF, quantifies this resistance. A higher COF means greater force is needed to initiate or maintain movement. Carpet has a higher COF than ice, thus more force is needed to move an object. Pushing a chest across carpet requires more effort than pushing it across ice. Leonardo da Vinci invented ball bearings to reduce friction. Ball bearings enable rolling motion instead of sliding. Rolling motion significantly reduces friction between surfaces. Reduced friction leads to improved efficiency in mechanical systems. This innovation allows for smoother and easier movement. Ball bearings are a fundamental component in many machines. Block 6. The flight of the soul, aerodynamics and the fluid air. Leonardo studied birds to understand aerodynamics. He recognized air as a fluid, similar to water. However, he noted air is less dense than water. This understanding was key to his inventions. His observations informed his flying machine designs. He aimed to replicate bird flight mechanics. Leonardo da Vinci studied birds in flight to understand aerodynamics. He observed how birds cut through the air. Da Vinci sketched birds to capture their movements. His observations led to insights into flight principles. As an object moves through air, it experiences a resisting force known as drag. The faster an object moves, the greater the drag force acting against it. This drag force is not linearly proportional to the object's velocity. Instead, drag is proportional to the square of the object's velocity. Doubling the velocity results in a fourfold increase in the drag force. This relationship is crucial in understanding aerodynamics and fluid dynamics. Extending a hand out of a moving car window illustrates air resistance. Air resistance is the force opposing an object's motion through the air. The faster the car moves, the greater the air resistance experienced. This increased resistance is felt as a stronger force pushing against the hand. The sensation demonstrates the direct relationship between speed and air resistance. Air resistance is a crucial factor in vehicle design and aerodynamic performance. Leonardo da Vinci explored flight through manipulating air resistance. He designed parachutes to increase air resistance for controlled descent. Parachutes aim to slow the fall, ensuring a safe landing. Leonardo also conceived aerial screws, early helicopter prototypes. These screws were designed to generate lift through rotation. Both concepts showcase his innovative approach to flight control. Leonardo da Vinci studied bird flight to understand aerodynamic principles. He aimed to replicate these principles in his flying machine designs. A key focus was minimizing drag, the resistance an object faces moving through air. He shaped his machines to reduce drag and improve aerodynamic performance. This optimization was crucial for achieving sustained and controlled flight. Leonardo's work provides the basis for modern aerodynamic study. His insights enable the design of efficient aircraft. His work also influences the design of other vehicles. Leonardo's contributions are foundational to aerospace engineering. Discover more physics content on our channel. Expanding your knowledge of physics is easy. Explore our videos to deepen your understanding. Learn more about the universe around you. Continue your physics journey with us today. Support the channel by liking the videos. Subscribing helps us create more content. Your support fuels ongoing content creation. Understanding the universe through physics is a journey. This journey of learning is extensive and continuous.